Welcome to the final part of our Posterior Mediastinum series. We hope you are enjoying it, and we will finish off the series with a look at the sympathetic nervous structures and the muscles in this area. I want to leave up that picture so that we can make sense of this. And this is just like the anterior chest wall with our intercostal muscles having the VAN sort of layering of the veins, arteries, nerves. So a vein is the posterior intercostal vein. The artery is the posterior intercostal artery. The vein is from azygos or one of those three, and the artery is from the aorta. So we know where the vein and the artery come from. Where does the nerve come from? That's really what we're trying to explore now. So in order to talk nerves, we're actually going to take one side, and I'm going to pick the right side, very purposefully. The left side, you can look at it looks fine, it's great, but our aorta is blocking some of these structures. So if you're looking for some of your nerve structures on your left side, probably you're having trouble. You have to lift up the aorta, you gotta dissect underneath in order to see that stuff. But we're actually gonna look from a view where we're like looking in a window of our right side so we can see those nerve structures that are not in this picture. Okay, I'm gonna explain it. I know it looks a little strange, but this is kind of the view from dissection that you're gonna see. And it's the one I want to bring up because it's the one that's most applicable to you, really. This is my upper limb, head and neck are over here. This is neck, upper limb. You've dissected the back probably at this point, but I just put it in like that. And then this would be the abdominal region that we haven't gotten to yet. And then we've opened up the chest cavity. We're ignoring our left side and pretending that there's stuff there and it's blocking everything. And what we can see here is the vertebrae and the ribs of our posterior mediastinum, the back wall, backside of our thoracic wall. We've peeled off that parietal pleura, and now we're actually going to add in structures so that we can see them. And the first one I'm going to start with is the one that's running along the sides of my vertebral column. It's on both sides, but I want to show you what it looks like when you actually see it. So coming down like this behind diaphragm. And what it has at every sort of spinal level is a bulge. People describe it as beads on a string, and I didn't make enough ribs. It's not an accurate number, but you don't need an accurate number. You just need this picture to make sense. So this thing that's on both sides, but we're ignoring one side of our thoracic cavity, is called the sympathetic chain or sympathetic trunk. Now, if I want to get specific, so I can put another version of it over here. Bead, string, bead, string, bead, string. The sympathetic chain is a nervous structure, so it's made of nerves, and it is the structure that is sympathetic. So if our parasympathetics are our rest and digest system, what does my body do when it rests and digests? If we're talking thorax, we're talking when we're resting, our heart rate decreases, respiration rate decreases because you're resting and digesting. You would be doing peristalsis, is moving things through your guts, esophagus included. So that is resting and digesting. That is the parasympathetic system. That is not this structure. This structure is our sympathetic system, part of it. And our sympathetics cause us to fight or flight from a situation. So this system and this structure is carrying nerve impulses that cause your heart rate to go up and your breathing rate to go up and your eyes to widen and your body to get ready to fight or run away. So this is the sympathetic chain. And each one of these things that is a bead on the string is a ganglia. And a ganglia, this is terminology stuff that I feel like just no one ever talks about, is a collection of cell bodies. What? Nerve cell bodies. So this is a collection of them, right? A ganglia is a bunch of nerve cell bodies. So where the nucleus of the nerve cell is in the ganglia when it's in the peripheral nervous system. What do we call collections of cell bodies in the central nervous system? We call them gray matter or nuclei. Those are collections of cell bodies. It looks darker on histology. That's going to be a collection of nucleuses which exist in the cell body, whereas the portion of our nerve called an axon, that is the way the signal travels, is going to be in the trunk portion. So in between the beads is actually axons. Anytime we talk about nerves in general, honestly, the nerve, the radial nerve, is really a bunch of axons bundled together. This is different. This is where we have some cell bodies in our peripheral nervous system, not in our central. Our central nervous system is our brain and spinal cord. This is outside of our brain and spinal cord. Therefore, this sympathetic chain is ganglia. The beads on the string are collections of cell bodies, sympathetic neurons, cell bodies, and then in between there's axons. And everything else I talk about in this is going to be axons as well. And I'm sorry if that was a little confusing. I really need to do a more thorough, in-depth version of sympathetic nervous system because I love it and we need to know what things are. So with that in mind, these are ganglia and in between is axons and they're all sympathetic. Only sympathetics get to use the sympathetic chain. And off of those little beads are two little connections. There are two little things coming off of these beads, every level. And I'm going to draw a bigger picture of it here as well. And I guess we're going into it anyway. Here we go. The quickest introduction to the sympathetic nervous system that ever existed so that you can understand the posterior mediastinum is happening now. This is a slice of your spinal cord. And I'm going to get a little specific. This is a slice of your spinal cord between the levels of T1 to L2. Okay? Anywhere there. So like if this is the brain, this is the spinal cord, anywhere between T1 and L2, I sliced it, and then it looks like this. And remember, structures come off bilaterally off our spinal cord, but I'm not going to do that. I'm just going to show it to you on one side. If you watched my brachial plexus video, you would have seen some of this, and it may be more familiar to you. I just made a lot of things, but remember, this is a quick review, not an in-depth review. We're doing this very, very quickly. So gray matter is where we have cell bodies in our central nervous system. Our brain and our spinal cord are our central nervous system. In our central nervous system, the cell bodies of our neurons are in this gray matter. The axons, also known as tracts, spinal tracts, are just axons going in different directions to different places, our white matter. So off of that is our peripheral nervous system. Anything outside of the brain and spinal cord is peripheral nerve. On this side, where we have a ganglia, which we now know is a collection of cell bodies, we have a ganglia on this side that is actually for our sensory nervous system, and that is completely different than our sympathetics and our parasympathetics. That's going into our dorsal aspect. So this is the dorsal or posterior, which is what dorsal means, side of our spinal cord. So this is where the spinous process would be and that sort of thing. So this is more anterior, also known as ventral, which means this is our dorsal root with the dorsal root ganglion, the DRG. Everybody loves it. This is our ventral root. Harder to see in anatomy, but this is the ventral root. And then what's this? This is a mixed spinal nerve. I wish my handwriting was better. It's just not. And then this mixed spinal nerve splits very quickly. I just kind of exaggerated it. One branch goes off dorsally. That's our dorsal rami. And one branch goes off anteriorly. That's our ventral rami. We name a lot of ventral rami. We don't name very many dorsal rami. When you learned the back anatomy, they probably just said innervated by dorsal rami, just dorsal branches of spinal nerves. Whereas these are ventral or anterior branches of spinal nerves, which we give names to. Like first, right off the bat, when our ventral rami comes off the back, raise the belly button really quick. There's a vertebra, right? And here's anterior, there's my sternum. And we got ribs around. A ventral rami comes out of the spinal cord. A dorsal one goes up, might branch like this into your back muscles. But a ventral one will come anterior and wrap around the body like so. And it will give off branches as it goes. What is this nerve? It's an intercostal nerve. That's all it is. This is an intercostal nerve. We name it. It's a ventral rami that we name. At every thoracic spinal level, we have an intercostal nerve. It's going to go in between the ribs. This is what that is. So this is where that comes from. So now we know what that part is. This is our ventral rami. Is really an intercostal nerve for us. Posterior intercostal until it's called anterior intercostal. Interesting, right? That's what that ventral rami is. Where does this chain come in? Well, it comes in because of these little things. That's our sympathetic chain. How does it connect to the rest of the nervous system peripherally? It is hanging off of this mixed spinal nerve before it branches into ventral and dorsal rami. So we can see that here. It is hanging off the mixed spinal nerve by these two structures. And those two structures have names. This is the white rami communicans. White rami communicans, I'm just going to call it white rami, okay? We agree? This is the gray rami. They get their names due to myelination. Myelination is where you have myelin sheaths around your axons, which increase saltatory conduction, which means, in other words, it increases the speed at which the signal travels. So a white rami has axons that are myelinated, a gray rami does not have myelinated axon. Therefore, it's a little bit slower. Myelin equals speed. Okay, so a white rami and a gray rami attach to one ganglion at every spinal level. This is our sympathetic chain that has ganglia, which are collections of cell bodies hanging off of it. That's what you're seeing here. And the two little things are connecting us to the rest of the nervous system, essentially the rest of the peripheral nervous system. So I'm going to go through just one example of what this really looks like. So in our spinal cord, we have horns of our gray matter, which is really just sections of our gray matter. We have a dorsal horn, ventral horn, and then we have this lateral horn that we have only at specific parts of our spinal cord. Notice I made that very specific. In our lateral horn, there is a collection of cell bodies. I don't know if they even teach this anymore. It's in the IML, the intermediolateral column. If you don't need to know that, forget it. If you do need to know it, shorthand it to IML. It's a lot easier. It is a column of nerve cell bodies that exist from levels T1 to L2 or L3, depending on who you talk to, on both sides. And this is where our sympathetic cell body neurons exist, the presynaptic ones. I know, it's a lot of stuff. So we have cell bodies here of nerve cells. Before we move any further, we must be reminded of the fact that sympathetics and parasympathetics are not sensory. They are motor. They are involuntary motor, but they are motor all the same. I cannot consciously make my heart beat faster. It will do it on its own. It will do it automatically because the sympathetic and parasympathetics are in the autonomic nervous system, the automatic nervous system, I like to say. So this neuron has an axon that goes out the ventral horn because it is a motor nerve, and all motor things come out of the spinal cord ventrally. All sensory things enter the spinal cord dorsally. That is just a fact about the nervous system. So here's our sympathetic neuron. Its axon goes out the ventral horn into the mixed spinal nerve. I apologize, I cannot make these markers quieter. And it's going to get into the sympathetic chain through the white rami. So that is how we connect to the sympathetic chain. This is a presynaptic sympathetic neuron that is then going to do a variety of different things depending on where we are. I'm not going to get specific besides the next thing I say. Simplifying this concept down to more simple than it actually is, separate video on the details, is my sympathetic neuron, my presynaptic one. Pre means before, synapse is where the neurons interact with other neurons and exchange chemical information, neurotransmitters, all that jazz. So it's where it meets up with the next neuron. Postsynaptic neurons exist in these ganglia. That's what those cell bodies actually are. They're postsynaptic neuron cell bodies. They're in there. And some of those postsynaptic neuron cell bodies will have axons that go to the skin, and other of those postsynaptic nerve cell bodies will actually have axons that go into these structures over here. So I'm going to make two different nerves. Make one neuron over here and one neuron over here that goes into this type of nerve, just to cover the language. This axon going into this structure is called a splanchnic nerve. Splanchnic nerves come off of our sympathetic chain. And splanchnic means organ. So just like visceral means organ, so does splanchnic. Splanchnic means organ, visceral means organ. This is just another word for organ. And it's a nerve, so it's an organ nerve. And then usually you'll hear cardiopulmonary splanchnic. And a cardiopulmonary splanchnic is a organ nerve. What organs does it go to? The heart and the lungs, the cardiopulmonary organs. So they're named pretty naturally. Makes a lot of sense. But a splanchnic nerve will always go to organs, whereas a gray rami, let's say I synapsed on this other one, a gray rami will actually always go out to the skin. And when I say out to the skin, I don't mean that your sympathetic nervous system innervates your sensory. I think that's where people get confused. What it actually means is it goes to microstructures in your skin. So when I say that the sympathetic gray rami goes back into the mixed spinal nerve, out the ventral rami, and goes to the skin. What I actually mean is it goes to some microstructures in your skin that are made of smooth muscle, because this is autonomic, involuntary, can't go to skeletal muscle, can't do sensation because it's motor. So it goes to the erector pillae muscles that move your hairs on your skin, microstructure. It goes to your sweat glands and produces sweat. When you're nervous, you sweat. That's sympathetic nervous system. I do it all the time. And then lastly, it's going to go to the smooth muscle in the vessels in this area. So it is doing, if we simplify it, pseudomotion, pilomotion, and vasomotion. Pseudomotion, sweating. Pilomotion, hair movement. Erector pillae muscles, making your hair stand up when you're nervous. A lot of times when you're nervous, your sympathetic system is activated. And vasomotion, vasodilation, and contraction. So that is what we're doing at the skin. It is not doing sensory. No sensation. No sensation. Just microstructures, smooth muscle structures. That is the innervation through the skin pathway for sympathetics. The other pathway is through a splanchnic. And I had to bring it up, and I had to explain that, because otherwise none of this makes sense. Okay, now that we have an idea here of this, we can talk about the next thing, which is splanchnic nerves. So there are splanchnic nerves that go to your heart and lungs. I'm gonna draw some in just for the sake of clarity. These are going to your heart and lungs. They're cardiopulmonary splanchnics. The reality is you're never gonna see cardiopulmonary splanchnics. They're too small and there's too much stuff. Remember, I moved so much stuff in order to look at this. We are just looking at the posterior intercostal area and our vertebra. That's really, really deep. The aorta's gone. All that other stuff, heart, lungs are gone. Cardiopulmonary splanchnics go to the heart and lungs. They're very small. They're going to network all over those organs. So they are not visible to you, but they do exist. The ones that are visible to you might look something like this. And you'll see this on both sides. You'll see a matching one coming from the other side. That is a splanchnic nerve, but it's a specific splanchnic nerve. I'm going to draw in its brothers as well, but they're actually underneath the diaphragm, which is the structure coming up here, blocking our view of some of this stuff. This is my greater splanchnic nerve. My greater splanchnic nerve is one of these splanchnic nerves that comes off of multiple ganglia. It's got contributions from multiple ganglia, and is going to go back behind the diaphragm because the greater splanchnic nerve innervates a part of your guts. And so does the other splanchnic nerves that you're going to hear about. You're going to hear about a greater splanchnic nerve, a lesser splanchnic nerve, and a least splanchnic nerve. The greater is the one you'll probably see in the thorax. The lesser and least, unlikely. They're underneath that diaphragm. It's going to depend how big is this person's liver, how much of the thorax you're actually going to see. Because under the right side of your diaphragm is your liver. And if it's big, it's going to cover this stuff up. You may not even be able to see a lot of greater splanchnic if you have a really big liver. But if you have a smaller liver, you might see lesser, but you probably won't see least. That's down near T12. So these splanchnic nerves are coming off of our sympathetic chain medially towards the vertebra. Notice how they run in. That's important to see because the splanchnic nerve is the only nerve that runs in towards the middle where your organs are. The rest of your nerves, like your ventral rami that are connecting to this chain, but not really a part of it, are going to come out of the spinal levels. So you see the chain, and then you see nerves coming out from the chain that are intercostal nerves. These are posterior intercostal nerves. I showed you that picture of where they come from. This is ventral rami. I know that's confusing because we name these posterior, but the truth is they're ventral. In comparison to what? In comparison to dorsal rami that we can't see at all because they went to the back muscles. So a posterior intercostal nerve is actually an anterior rami. That's sometimes where people get mixed up. But these are posterior intercostal nerves. This is my sympathetic chain. Off of my sympathetic chain are a white and gray rami. I put them in this picture because sometimes you can actually see them. And then also the greater splanchnic nerve, maybe the lesser splanchnic nerve, and then our posterior intercostal nerves coming off towards those rib spaces. Now this is when I want to bring up the relationship. Vein, artery, nerve. So this is that VAN relationship. All of these are posterior intercostal. All of these are in order. It is V for vein, A for artery, N for nerve, posterior intercostal, VAN. Every level. And to be the clearest I can possibly be, they're always at the base of a rib. Why did I bring that up? Your ribs have a groove on the backside where these vessels are running. They're in that groove, that costal groove is where your vessels, your vein, artery, nerve, where you find these vessels. The reason that's important is because sometimes people stick needles into chest and they tell you do not shoot for underneath a rib because you can palpate a rib. You can find the bottom, you can find the top. Palpate means touch. And if you were to shoot a needle at the bottom of a rib, you might puncture an artery, you might puncture a nerve, you might puncture a lot of structures. So instead you shoot for the top of a rib because there's nothing you can damage there except for some intercostal muscles. Versus if you go here, you're going to hurt something. Vein, artery, nerve. Now we know they're all posterior costal. Now we know where they come from. And these are the nervous structures that we're going to see in this area. Besides the phrenic nerve, which will come down, hang around here, go to the diaphragm, and the vagus nerve that is much more associated with the heart and the lungs and the esophagus. Now the vagus nerve, for point of clarity, if the sympathetics we just talked about provide your fight and flight response, the vagus nerve is providing that parasympathetic side, that rest and digest side of our autonomic nervous system. We'll get way more into that in a different video. The very last thing I want to bring up is what we can see muscle-wise on the back side. So the last thing we need to cover is the muscles. What we can see is those innermost intercostal muscles just kind of on the sides. Because remember, their muscle belly is only kind of lateral. Then it becomes tendinous. And we can see the external intercostal muscles. Those are actually the muscles behind and interacting with these posterior intercostals. That's external intercostal because its muscle belly goes all the way back to the spine. So we have innermost and external intercostals that we can see on the backside, underneath our lungs, posterior aspect of our chest, of our thorax. And subcostals. What is a subcostal muscle? A subcostal, like our transversus thoracis muscle that spanned multiple rib spaces, is a muscle you're going to see every once in a while that cuts across multiple ribs. And you'll see them randomly, cutting across multiple rib spaces, kind of like so. If you see a muscle that spans more than just in between ribs, that is a subcostal muscle. And that is the end of posterior mediastinum. Thanks for watching. If you made it through the whole series, I hope it helped you learn posterior mediastinum. Subscribe to the channel if you want to see more videos, and we'll see you in the next one. Toodles!